welcome back to the course on computer graphics. Today I'm going to talk about general 3D rotation. We've already seen 3D rotation about around the coordinate axis, that is rotation around z axis, y-axis and x-axis. So now you are going to see general 3D rotation. Okay, a rotation matrix of any axis that does not coincide with the coordinate axis can be set up as a composite transformation involving combinations of translations and coordinate axis rotations. That is, what we have seen earlier is a rotation for any axis that coincide with the coordinate axis. Okay, so z axis rotation was for the object with an axis that coincide with the z axis. Okay, so similarly x axis and y axis for a different axis. Okay, so if an object is placed in an axis which is not a coordinate axis, then for such objects a composite transformation will be required. That is, a combination of translations and rotations will be required for such rotations. Okay, so it will be a composite transformation. So we are going to see some of the cases in which the coordinate axis of rotation is not the axis for rotation is not the coordinate axis. Okay, so first cases where an object is to be rotated about an axis that is parallel to one of the coordinate axes. Okay, so that is if the axis of rotation is parallel to the coordinate axis, that is if it is parallel to z axis or y axis or x axis, how you are going to perform rotation. So it will be a composite transformation, and the transformation sequence will be first a translation, that is translate the object so that the rotation axis coincides with the parallel coordinate axis. Then you perform the specified rotation about that axis, and then you translate the object so that the rotation axis is moved back to its original position. Okay, so first a translation, then a rotation, and then again a translation. Okay, so that is shown here. So P dash will be equal to T inverse dot R theta dot T dot P. Okay, so this P is our original coordinate xy, x dash y dash is the new position, P dash is the new position x dash y dash, and this T inverse R theta T, this is the composite matrix or the composite transformation matrix. Okay, and this composite transformation matrix is shown here, where the composite matrix for transformation is R theta equal to T inverse R I theta dot T. Okay, so here it shows the translation to its original position, rotation about that axis, and translation to the origin. Okay, so that is shown here. Okay, so this is rotation about an axis which is parallel to the coordinate axis. So this figure shows an axis which is parallel to x-axis. Okay, so in order to perform the rotation of this object about this axis, So this dashed line shows the rotation axis, and this rotation axis is parallel to x-axis. So how do you perform the rotation? First you have to translate this object to the x-axis, that's shown here. This rotation axis is moved to this x-axis. Okay, so now the rotation axis is this coordinate axis x. The object is moved here. Then you have to perform the rotation about this x-axis. Rotation about this x-axis. Okay, and then you perform the translation again, that is translation back to the original position. Okay, so this object is translated or moved back to the original position. Okay, so this will be the final rotated object. Okay, this is so this is the composite transformation for the rotation of an object which is having an axis parallel to the coordinate axis x. Okay. Similarly, there can be rotation axis parallel to y or z. You can do it in the similar way. If it is parallel to the y axis, then the rotation axis is first translated to the coordinate axis y, then rotated, and then moved back to the original position. Similarly for z axis also. Okay. Then that was the first case. Then the second case is when an object is to be rotated about an axis that is not parallel to one of the coordinate axes. We need to perform some more additional transformations for such cases. Okay, so we have seen the rotation about an axis that is parallel to the coordinate axis. Now we have to see an axis which is not parallel to the coordinate axis, how we are going to perform the rotation. Okay, so that is shown, one example is shown here. Okay, suppose this is the initial position of the axis. Okay, here the object is not shown, only the axis is shown using this P1, P2. Okay, this dash line shows the axis with which the rotation should be done. Okay, so in order to perform rotation of an object about this axis, okay, this is the axis of rotation. It is not parallel to any of this coordinate axis, x-axis or y-axis or z-axis. It's not parallel to any of these axes. Okay, for such rotation axes, how you are going to perform rotation? That's what we are going to see here. Okay, so what you do is, the step one is to translate this P1 to the origin. That is one of the points in the rotation axis. Translate the object so that the rotation axis pass through the coordinate origin. Okay, so in order to make sure that this axis pass through the coordinate origin, if you have 2 points P1 and P2, you make sure that the P1 passes through the coordinate axis when you are looking from P1 to P2. Okay, when that is you are looking to the xy plane. Okay, if you are looking in that direction, then the lower point P1 should be moved to the origin. Okay, so P1 is moved to the origin. Correspondingly, P2 also will be moved. Okay, so the new P1 will be P1 dash, and this is P2 dash. Okay, so that is step 1. Translate the axis to the origin so that the axis passes through the origin. Okay, so you translate it to the origin. Then next step what you have to do is, you have to rotate the object so that the axis of rotation coincides with one of the coordinate axes. Okay, so you have to rotate it so that it coincides with any of this coordinate axis. Okay, so here you are rotating this to z axis, onto z axis. Okay, this p1 dash, p2 dash is rotated so that it coincides with the z axis. See, this is the new rotation axis. Okay, so p1 dash, p2 dash, it passes or it coincides with the z axis. So you perform the rotation so that it coincides with the z axis. Okay, then what you do? After that, you rotate the object around the z axis. Okay, so to which you can rotate it so that it coincides with any of these axes. Here it is, here in this example you are coinciding it with the z axis. You can also do it with y axis or x axis. So since here we have coincided the rotation axis with the z axis, the object should be rotated around the z axis. Okay, so you are rotating the object. So if here is an object, you have to rotate it in the with the z axis. Okay, so you can use the equation to rotate it with the z axis, coordinate axis z. Okay, so so the object will be rotated here. Then what you have to do? Then you have to move this back to the original position. Okay, so you have to perform the inverse of the these step 1 and step 2. Okay, so first you have to rotate it back to the original orientation. Then you have to move it back to the translate it back to the original position. Okay, so and then you have to, after rotating the object, you are going to rotate the axis to the original position. So p2 dash, p1 dash, p1 p2 dash dash will become p1 dash, p2, like this. Okay, so you perform the inverse of this rotation. Step 2, we have an rotation from the p1 dash p2 position to p1 dash p2 dash dash position. So that rotation is inversed in step 4. Okay, and similarly then you have to move it back to the original position p1 p2. So again you are going to rotate, translate this axis back to the original position. Okay, p1 p2. Okay, you perform the inverse of this step 1 translation so that you get the step 5 translation. Okay, so you move it back to this position p1 p2. Okay, that's how you perform the transformation or rotation in case of axis which is not parallel to the coordinate axis. Okay, a rotation axis can be defined with two coordinate positions or with one coordinate point and direction angles between the rotation axis and two of the coordinate axis. Okay, here in this example, you have defined it using 2 points P1 and P2. Okay, here you have defined this rotation axis as P1, P2. You can also define it using one coordinate point and the direction angles between the rotation axis and the coordinate axis. Okay, so here we have assumed that it is defined by 2 points p1 p2 and the direction of rotation will be counterclockwise when looking from p1 to p2. Okay, that is an assumption. Okay, so this vector, the axis vector, is defined by v is equal to p2 minus p1. Okay, so this rotation axis can be represented as a vector and that vector v is equal to p2 minus p1. That is the values will be x2 minus x1, y2 minus y1, z2 minus z1. So this vector represents the axis vector, that is our rotation axis. Okay, and from this the unit vector u is defined along the rotation axis as v by magnitude of v. Okay, so unit vector defines the direction of the rotation axis. So this can be defined, this unit vector is defined as u, and that is equal to v, vector v by magnitude of v, and that is that is represented as a comma b comma c. Okay, so that is our unit vector, and the components a, b, c is a is equal to x2 minus x1 by magnitude of v, then b is equal to y2 minus y1 by magnitude of v, and c is equal to z2 minus z1 by magnitude of v. Okay, so these are all some of the things that we'll require in determining our composite transformation. Okay, so first what you are going to do in rotation is, first step is to translate the rotation axis to the origin. Okay, so you have to move the rotation axis so that it moves to the, or it passes through the coordinate origin. Okay, so we accomplish this by moving P1, the point P1 to the origin. Okay, we've already seen this here. So you have to move this P1 to the origin so that the rotation axis passes through the origin. Okay, for that you are performing the translation. So the translation is done from the point P1. So P1 is x1, y1, z1 to origin. So you have to rotate in, you have to move it in the opposite direction, so that you have to move it back to the origin. So minus x1 minus y1 minus z1. Okay, so the translation matrix will be like this. So 1 0 0, translation vector will be minus x1 minus y1 minus z1. Okay, so tx, ty, tz, it will be minus x1 minus y1 minus z1. Okay, so 1 0 0 minus x1, 0 1 0 minus y1, 0 0 1 minus z1, 0 0 0 1. Okay, that is our translation matrix to move the rotation axis so that it passes through the coordinate origin. Okay, so that is the translation matrix. Then second step, you have to perform the rotation about rotation of this axis so that it passes through any of the coordinate axes. So here in this example we have rotated this rotation axis P1 dash P2 to Z axis. Okay, so that rotation is performed. Okay, so how do you do that? You can perform this rotation in two steps. Okay, so that it get aligned with the coordinate axis. Okay, so you can do this in many different ways. Here it is one of the ways in which this rotation can be done. Okay, so we first rotate this vector about the x-axis to transform the vector to xz plane. So here the rotation is, here the vector is something like this. The unit vector u will be, that is the direction of this P1 dash P2. That is represented using a unit vector u. So that vector will be something like this. So what you do is, first you rotate it about the x-axis so that it is in the xz plane. So this is our xz plane. So you rotate it to the xz plane. Okay, so that is shown here. This p1 dash p2, which is in the direction u, or with the unit vector u, is rotated to the xz plane. Okay, then in the second step you swing it around the z axis using y axis rotation. Okay, so the vector or the rotation axis is now in the xz plane. Now you have to simply swing it to the z axis, but here it should be swinged in the counterclockwise direction. That's why it is swinged like this. Okay, so you have to swing it to the z axis, and for that you can use y axis rotation. Okay, so first you have to perform an rotation about the x axis, and then you have to perform a rotation about the y axis to move this rotation axis p1 dash p2 to the coincide with the z axis. Okay, in two steps you can get that. So the rotation axis can be represented like this. So the first is we can set up the matrix of rotation u about x axis like this, then about the y axis like this. Okay, so about the x axis, rx alpha. Alpha is the angle with which it should be rotated about the x-axis. That is represented by 1 0 0 0 0 c by d minus b by d 0 0 b by d c by d 0 0 0 0 1. A, B, C, D values are we have determined already. Okay, then similarly, after rotating about the x-axis, it is now in the xz plane. Then you have to rotate about the y-axis with an angle beta, so that it comes in alignment with the z-axis using this rotation matrix, that is transformation matrix, that is d0 minus a0 0 1 0 0 a0 d0 0 0 0 1. Okay, so first you have seen the first step this translation matrix will be used. In the second step you have to rotate it so that it comes in alignment with the z axis. For that you do two steps of rotation, that is the rotation about the x-axis, you use this transformation matrix. For the rotation about the y-axis, you use this translation matrix. And then in the third step you have to rotate the object about the z-axis. Okay, so we have a specified angle theta. Using this angle theta you have to rotate the object around the z-axis. So for that you use this rotation matrix, that is cos theta minus sin theta 0 0 sin theta cos theta 0 0 0 0 1 0 0 0 0 1. Okay, and to complete the required rotation about the given axis, we need to transform the rotation axis back to the original position, and this is done by applying the inverse transformations. Okay, so after performing this rotation you have to move that rotation axis back to the original position, so you have to perform the inverse transformations. Okay, so what you have done here, you have to perform the inverse of it. So you have to rotate it back to the original position u. U is the actual direction of a vector. To move to the that vector you have to perform inverse rotations, and then you have to move it to its original position. So for that you have to perform inverse translation. So that is shown here. Okay, so you have to pre-multiply it. So that means you have to perform all this transformation in the order from last to first. Okay, so that is shown here. So the first translation is t, then you perform rotation about x-axis, then you perform rotation about y-axis, then you perform the rotation of the object about the z-axis, then inverse rotations are performed, then last you perform the inverse translation so that it is moved to the original position. So the composite transformation is represented here. Okay. So that is general 3D rotation. With this you have completed fourth module. Thank you.